So, good evening, everyone, and welcome to this fantastic day with a fantastic topic electrostatics. And we are still on to electric field. I know that you have done electric field twice. This is the third time that you are doing it, but can't help it. This is how we have to go about. We have seen what is electric field. We have seen what is the intensity of electric field. Intensity of electric field is the thing that we are concerned about right now. And we will be finding out electric field due to different configurations. No, we are not going to find them out. We're just going to note their results. And then we'll be solving some questions which are the prime suspects here. But before going any further, let us first note down a few points about electric field. If you know these points, you may not have to note them down. Just tick them from wherever you are. We have made previous notes. You can tick them on those previous notes. If you don't have them, well, you can write. Electric field is a vector quantity. It has the direction of electric field is same as the direction of positive charge, the direction in which the positive charge experiences a force. I hope we know this. Yes or no?
Yes,
Now,
sir.
whenever we have electric field due to a positive charge, it is always away from a positive charge and it is always towards a negative charge. We know this? Yes or no?
Yes, sir.
Nah. The other 2 points are the units and dimensions. Please note their units and dimension very carefully, because a lot of question comes on units and dimensions of electric field, magnetic field, epsilon naught, mu naught. So these things must be at the back of your hand. As soon as I ask, what is the dimension of electric field? Say, yes, sir, this. What is the dimension of mu naught? Sir, this. You should not even think for a second. These things should be so good, no confusion, and you should be able to give me the answer. I hope you understand this. Most of the question that I have seen in JEE, either they will be based on mu naught, epsilon naught, or they will be based on the Planck's constant. These are the three, or gravitational constant. These are the four things that I find universally whenever a question of units and dimension has ever come in any JEE. So remember those. The next one, again, if you place a positive charge in an electric field, it will experience force in the same direction as electric field. This concept has been given to you many times. I'll keep on saying that because we will be needing it in solving questions. Next one, electric field, again, is a vector quantity. Force is a vector quantity. If a charge is experiencing more than one force, to find out the net force, to find out the vector addition. Similarly, electric field is the vector addition of different electric forces. Do we understand this? Yes or no? Huh?
Yes, sir.
We'll just start with a very simple question. Question from your module. I think you would have done this, but again, it's my responsibility to check out whether you know this or not. So this is a very simple question, because this question actually comes in different ways. Will also come in a chapter known as magnetic field, where we are going to balance this charge not by electrostatic field but by magnetic field. So remember, this is the electrostatic variation of that question, which is going to come maybe in the next month when we do magnetic field. Find the electric field intensity. That would be just sufficient to balance the weight of a particle of charge minus 10 microcoulomb and mass 10 milligrams. It's just 10 milligrams, very small particle. How much electric field do you need to balance its weight so that it does not go down? Eh? Any idea? No idea. Get idea. First of all, tell me this thing. In which direction should I apply electric field? Because the question that I'm going to do in magnetic field, the first part of that question is to find the direction. If this is your charge, and I hope you can see this, if this is your charge, minus 10 microcoulomb, it is obviously in a gravitational field, so its weight is going down. In which direction should I apply the electrostatic field? Up, down, right, left, upper, niche, where? Huh?
Up, sir.
Up, sir. Why, sir, up, sir?
To balance it.
To balance it. Well done. We'll have to apply electric field in the upward direction. We all understand this, yes or no? How many of you understand this? Please raise hands. Everyone understand it, and that is why we have done it twice, and that is the need that we have to do it a third time. Because negative charge experiences force in the opposite direction. So you cannot apply electric field upwards. You have to apply electric field downwards. So you understand why we are doing for the third time? That is why we are doing for the third time. And this thing, just now in this today's class, I have repeated at least 4 times. At least 4 times I have repeated it. Here, dang, 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 dang. Here, dang, 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 dang. And we are doing it for the third time. Then still we give the answer as upwards. So be very careful, because this upward, and that was the only reason I gave you this question, because I knew that you are going to say upwards, because that's an instinctive answer. But our instincts may be wrong at certain times. Do we understand this? The electric field has to be downwards, because then only it will produce a force upwards, because the charge is negative. You understand this now? Yes, sir, or no, sir?
Yes, sir.
Good, sir. Now give me the answer, sir. Eh? Answer is not coming? Don't worry. When I say that I am covering a topic, I will cover it in all aspects. I will not leave anything for chance. You said that you have done dipole, but trust me, I'll also do dipole. But I will not do it here, I'll do it somewhere else. I'm not going to leave anything to chance. And I have all these recordings. So if someday you tell me, sir, we have not done this, I will show you the recording. See, in this lecture at 15 minutes, I told you this. So I have everything recorded with me. And I'll remember in which lecture I have told you what. Yes, any answers here? Eh? No one knows the answer. It's a simple question. I have to balance the weight. No one? It's a simple question here. Anyone, any idea what will the answer? Any guesses? Anything? No one has any answer. Just because you gave me the direction of electric field wrong, that does not mean that you are going to give the answer wrong. Sometimes we don't understand the question, but we get the right answer. That is dangerous though. Now you understood the electric field is downwards. What is the answer? Yes? No one is saying anything. They are thinking that if I say something and it is wrong, sir is going to shout. I am going to shout anyways. You give the answer, I'll shout. You don't give the answer, I'll shout. So it's better to give the answer and then hear the shouting, rather than keeping your mouth shut and then hearing the shouting. No one knows the answer? Seriously? Then I'll solve it. So the weight mg is downwards. Someone has to balance it. Who is going to balance it? It is the electrostatic force which is going to balance it, and that is simply equal to Q multiplied by E. These two forces should balance each other out.
10 to the power of -4.
So Q into E. Arey, what now? Now I'm solving it. You have to set this answer 1 second, 2 seconds before, na? Electric field. The answer that I was looking for was this, sir. It is simply equal to mg by q. You put the values, you get the answer, and you stay happy. That was the answer. You put the values, get the answer, and you stay happy ever after. Everyone understands this? Yes or no?
Yes, sir.
Okay. Now, since we are here and we have seen a charge getting balanced, let me see if I can get that question that I have in mind. So let me solve that question. And then I will move ahead. Actually, I was thinking of doing something else before first. But since I have done this question, let me see if I have a question that I have in mind. Otherwise, I'll have to make it. If I make it, if I have it, then it's easier to. Do I have it? Do I have it? I must be having it. What is this? Yeah. What is this? What is this? What is this? What is this? Here it is, but then you'll have to know that to know this. So you can't do this. You can't do this from here. So let me try it from here. No, don't have it here. Don't have it here. Again, these are it's here. Chalo, I got it. I have this, so I can now put my questions because I have a question in the written form. Okay, so here comes the question that I was desperately searching for. Let's see if you can do this. Uniform electric field is created between two parallel charge plates as shown in the figure. So I have to show you the figure as well. So not a problem. I'll show you the figure. And I'll ask a couple of questions in this. Remember that the same question will come in magnetic field also. This is the electric field version of this question. So a uniform electric field is created between two charge plates as shown in the figure. An electron enters the field with a speed u. The length of each plate is L. Find the angle of deviation of the path of the electron as it comes out of the field. Now this question may look very very enterprising, but I am going to split it into simple parts. What are the simple parts? This question is going to come. They can ask you a lot many things that in this question can be asked. The first thing is how much time. See, the length of the plate is given as L. Forget about what is the main question. Can you tell me how much time does it take to cross the plate, to come out? That is the first question that you forget about what is being asked in the question. If you can give the answers to my question, simply you will get to the last part of the question where you will have the answer of the remaining things. How much is the time taken to cross the plate? Remember, in between this plate, gravity is not present. Forget about gravity. Gravity is not there.
L by U, sir.
L by U, sir. How did you get L by U, sir?
Length is equal to UT.
Length is equal to UT. So your U is not going to change. Why is it not going to change? What is the reason for U not changing? The answer is right. What is the reason of your U not changing? That is what I'm asking you. So that I'm sure that you understand what is happening here and this is not a fluke. Yes, why is U not changing? What is U and why is U not changing?
Long x-axis is constant.
Okay, so this is actually the parabolic motion, motion under gravity, but happening in the reverse order. The gravity force was acting downwards. Here, instead of gravity, it is the electrostatic force which is acting upwards on this block. And how much is the electrostatic force which is acting upwards on this body? It is QE. It is a negatively charged body, so it will be attracted towards the positive plate. So the acceleration of this body will be QE by m. Do we understand this? So if I write the equation of this body, the initial velocity along x will be u and it will be constant. So this is a sort of revision of your chapter on motion in 2D. And that is the reason I was supposed to do this. Initial velocity along x is u and that will remain constant. All of us understand this? Yes or no?
Yes, sir.
Initial velocity along y is 0. There is no y velocity. Acceleration along y will be equal to your QE by m in the upward direction. So I will call it as positive. Now you can answer whatever questions they are going to ask. If you remember this, you should be able to answer whatever questions they are going to ask. For example, question number 1, time taken to cross. Time taken to cross. Now it has to move a horizontal distance of L and the velocity along horizontal is going to remain constant. So you can write this L as ux, which is u multiplied by t. That tells me that the time it will take to cross will be L by u. Everyone understands this? Yes or no?
Sir.
Okay. Then in this question, what they have asked is the value of this angle deviation. Now, how do you get this deviation? Don't just panic. This is basically the angle your final velocity at this point V makes with your x-axis. Do we understand this? Now, how do you find this angle? The tan of this angle theta will be given by your Vy component divided by your Vx component. We understand this?
Yes, sir.
Your Vx component, my dear friends, is going to remain constant. It is equal to Ux, which is equal to U. The only thing you have to do is find the Vy component. How will you find out this Vy component? For this, you make equation of this particle along y-axis. And now I'm going to make this equation. Vy will be equal to Uy plus Ay times T. Everyone understands this?
Sir.
Uy we already know is 0 from here. Acceleration along y we know it as QE by m. Time we already know as L by u. We can put this, we can get the value of Vy. From there you will get the value of tan theta. From there you will get the value of theta, and that is the deviation of the part. I have seen this question come many times in many exams, and that is the reason I have done this. I have different variations of this question, but they have all these numerical values. I don't want you to get caught in numerical values. This is the only question that I found in the algebraic form. What is the value of tan theta? I solved all the questions here, don't worry. What is the value of tan theta or theta? Huh? No one knows it. Anyone with an answer? Tan theta or theta?
QEL by MU square.
QEL by MU square. That is correct. Wrong color I have used. The value of tan theta is going to be coming as QEL by MU squared. Well done. Everyone understands this? Yes or no? Huh?
Yes, sir.
Have you done this simple harmonic motion? Yes, sir, or no, sir? Have you done simple harmonic motion?
Today itself started, sir.
Today started. Who has started this?
Satyendra, sir.
Okay. Anyways. This question has got very little to do with simple harmonic motion. Do you understand the meaning of time period? Yes or no?
Sir.
You understand the meaning of time period, na? Tung, 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 tung. Time period, everyone knows that? Time taken to complete one cycle? Yes or no?
Yes,
Huh?
sir.
This is a question you might have seen it in, I think, SC Verma or so. Anyways, since we are doing this question, do this one as well. There's a point that I want to make here. So this is a question: a block of mass m containing a charge q is placed on a smooth horizontal table which terminates in a vertical wall as shown in the figure. The distance of the block from the wall is d. A horizontal electric field towards right is switched on. Assuming elastic collision, find the time period of resulting oscillatory motion. Is it simple harmonic? I can tell you it is not simple harmonic. Can you find out time period of this oscillatory motion? Can you find out the time period of this oscillatory motion? Yes or no? You have 2 minutes to do this. This is not simple harmonic. This is oscillatory. You have 2 minutes to show your talents. Do you need any help? Shall I help you?
1 minute, sir.
Yes, I have 1 minute. Don't worry. There's a reason that I am doing this question, and I'll tell you the reason also. Shall I do it, bacha, for you?
Yes, sir.
Given up?
Given up.
Okay. Not a problem. Try to see and try to understand and then reason. What you got to do here? Nothing special, actually. What's going to happen? I hope you understand the meaning of elastic collision. Yes or no? Huh? Yes? No. Do you understand the meaning of elastic collision?
No, sir.
Oh, that is a problem. Elastic collision means whatever velocity it strikes, the same velocity it comes back. You understand this? Whatever velocity it strikes, the same velocity it comes back. So if this gentleman reaches this point and it hits the wall with velocity v, it will rebound with the same velocity v. That is known as a perfectly elastic collision. Do we understand this?
Yes, sir. So T
Now can
equals
you
to
do it?
2 pi root over k q square by md.
Yes, sir, I got an answer. Good, good. What is the answer then?
T
Yes,
equals to 2 pi root over k q square by md.
K. How does K come here? K. I think you have understood the concept, but probably got confused with K. Now remember, it was at rest at this point. At this point, this particle is at rest. It is going to get accelerated and it has to travel a distance d. You know the acceleration of this particle, it will be equal to QE by m. We understand this, yes or no?
Sir.
You just have to find out the time it hits the wall. How will you find out the time it hits the wall? This acceleration is constant, my dear friend. So you can apply that old formula from first chapter. What was that old formula? Displacement delta r is equal to ut plus half at square. We remember this old formula? Old, very old.
Yes.
Better than me.
Sir.
Yes, here the initial velocity is 0. The displacement is given as d. You can find out the time t. Tell me what is the time t coming from here? Huh? Tell me the time t coming from here. Everything is right there on in front of your screen. What is the time t?
Root over 2 delta r by a.
Root over 2. Arey, where is Emma? Emma! 2 times m into d divided by q into e. Your displacement is d in this question. Do we understand this? So this will be the time. Now, this is 1/2 of the revolution. Now it will again come back. And when it comes back to the initial point, that is the total time period. Do we understand this? Yes
Sir.
or no?
Yes, sir.
How much time will it take to come back, my dear friends? How much time will it take to come back? It went and thappi, and then it's going to come back. After how much time will it come back to its original position?
Same, sir.
Same, sir, because this is motion with constant acceleration, sir. It is same, sir. So the time period is 2 times of this. And that was the question. The time period is 2 times of this. Do we understand this, or this has gone above our head saying bye-bye?
That's it, sir.
See, if you see this question and you look at this Krantikari question, both the questions are same. You have this as floor and you have a ball which falls on this floor from a height h and it rebounds elastically. How much time will it take to come back? Same. Do we understand this? Same question. Whether the question is this, or this. It is same. Do we understand this? Huh?
Yes, sir.
Same question. So questions on this electric field is same as gravity turned by 90 degrees. You turn the question of gravity by 90 degrees and you get the question on electric field. Here. Turn it by 90 degrees and you have a question on electric field. This question or this question, they are same. The time period is this one. We understand this?
Sir.
Chalo, one more question. And again, I'm doing it as a revision thing. This question, you always ask for revision. This question, we revise motion in 1D. In the question before that, we revise motion in 2D. And now comes the next one. Again, revision of what we had done. And we are doing it in a new way. This is the next question, sir. Find U min, so that the particle will complete the circle. Now, this is a revision of your motion, work, power, energy, circular motion. Tied, particle tied to the end of the thread, and you know how does you remember that? Ding 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 ding. Yes or no?
Yes, sir.
Many
Tension.
people have asked me question on work, power, and energy. So this is the time where we can solve one or two of them. Work, power, energy. Ding 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 ding. So now ding 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 comes to you. Here, apart from the force of gravity, they have also put your electrostatic field. Good luck. Tell me the answer. I hope everyone is trying and you are not doing ding 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 ding. Huh? Everyone is trying the question now? That should remind you of this work by energy. What is the velocity here and velocity there and this and that. So I found some interesting question so that everything gets revised. Eh? Eh? Yes, my dear friends. Anyone with any answer? Anything that looks like an answer? No one? Does anyone remember when does it complete the circular path, bacha? Does anyone remember this? Does anyone remember when does it complete the circular path? If you don't remember it, you can't do it. It's as simple as that. Yes, bacha. When does this complete your circular path? I understand that it was done 1 year back, but do you have any memory? If not, then I'll let you do it because you can't do it then.
Minimum velocity to overcome top point, sir.
Yes, to how much is that?
Root over 2 GL.
Huh? Root over 2GL? No, it's not root over 2GL. Who said so? No. Did we cover work per energy? Did we do work per energy?
Yes, sir.
Then you don't remember it. So what you're going to do is going to go back and see how much velocity it needs. At the lowest point, the velocity for it to complete a circular path when it is not confined to a circular path, when it's attached to a string, is root over 5GL. Do we understand this? Root over how much?
Root
Huh?
over 5GL.
Root over 5GL. Now, just to give you a recap, write this. I just took a class with those what you call them? What you call them? Whatever your senior batch, whatever. So just a quick recap of this, your work, power, and energy. A quick recap, a recap of 5 minutes. Do you see this? This is from their notes. Do you see this?
Sure.
See, so this is a body which is not confined to a circular path. It is a body which is attached to a string. Do we see this? Body attached to a string. Dong, 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 dong. For this body to complete the circular path, the tension at the highest point should be greater than or equal to 0. Do we understand this?
Sure.
Yes or no? For tension to be greater than, if you don't know, remember it. Write it. If for tension to be greater than or equal to 0, the minimum condition is the tension must be equal to 0. For that to happen, the velocity at the highest point, which is point C, has to be root over GL. Understand this?
Sir.
For that velocity at the highest point to be root over GL, the velocity at the lowest point should be root over 5GL. Do we understand this?
Yes, sir.
Remember this. Now, these are the different cases, and this is a summary of all the cases put together. If the velocity at the lowest point, let me rub this everything out. If the velocity at the lowest point is root over 5GL, the tension will be 6 mg. Potential energy at the lowest point is taken as 0. Forget about radial acceleration, you might not need it. The velocity at the B and D are middle points. You subtract 2 from here, it will be 3GL. You subtract 3 from here, it will be 3 mg. You again subtract 2 from here, it will be root over GL. You subtract 3 from here, it will be 0. This is the way I have asked them to remember. This is definitely the same way in which I asked you to remember it. Work, power, and energy. This is motion confined to a circular path. You can go back to your notes and see whether you have written this or not. Okay, do not write this general point. Just write these 3. More than enough. Do we understand this?
Yes, sir.
Yes,
Okay. Now see, I gave them this example. What will happen if the velocity at the lowest point is root 6GL? Now, if you just apply common sense from the table above, if the velocity at the lowest point is root 6GL, tension at the lowest point, you add 1, will be 7 mg. Do we understand this?
sir.
Velocity at point B, you subtract 2 from here and you will get the velocity at point B, root over 4GL. Do we understand this?
Yes, sir.
You subtract 3 from this and you will get the tension at the point B, 4 mg. Do we understand this? To get the velocity at the highest point, you again subtract 2 from it and you get the velocity at the highest point. To get the tension at the highest point, you subtract 3 from this and you get the tension at the highest point. So tension goes down by number of 3 and velocity goes down by number of 2. Do we understand this, or this has gone above and saying bye-bye?
Understood, sir.
Okay. Again, a similar case where the body is not attached to a string. The similar case is when body is on the inner surface of a circle. Whatever job tension was doing there, normal reaction is doing here. So the same case, only in case of this particular thing, in place of tension, you have normal reaction. Do we understand this?
Yes, sir.
That's it. Not that it, that this is a summary of everything together. So this is a summary of everything together. What happens when velocity is what? If the velocity is more than root 5 gr, case number 1, it will complete the path very easily. If the velocity is actually equal to root 5 gr, it will just complete the path. If the velocity is equal to root over 2 gr, it will just reach point B. This was the number that you probably remembered when you said root 2 gr. This was the velocity which you remembered. With this velocity, it will only get to point B, which is the middle point, my dear friends. If the velocity is less than root 2 gr, it will even not reach that middle point. Velocity will become 0 somewhere and then it will come back. Do we understand this?
Yes, sir.
Then the last case that remains is when the velocity is in between root 2 and root 5. In that case, tension will become 0 at some point and the body will follow projectile motion. Do we understand this? This was the case of body not confined to a circular path. We remember everything now? Got this? Then there was a case, if you remember, of body confined to a circular path. There is a body attached to a rod. It cannot leave. And in that case, the velocity, everything else remains same, but the velocity to complete the circular path is root over 4 gr. So just remember it. You can revise it once you go back home, give it 5-10 minutes, and I think you would be able to recollect what we had done in those classes. Coming back to this question now that we are doing, I've talked non-stop for 15-20 minutes. What is the answer for this one? You have 2 minutes still to get me the answer. Yes. Anyone with anything that looks like an answer? Sounds like one, looks like one. What is the answer now? I have told you so many things. I have told you the entire Ramayana and now I'm asking you who is Ram? And you are thinking, who is Ram? Oh, looks good. The name is good. Let us think, who was Ram? Ram was the prince of Ayodhya, son of the great king Dashrath and the eldest of the queens. Kaushalya? Yes, probably. He was the bravest of the brave, avatar of Lord Vishnu. He came on this earth to kill Ravana. That was Ram, Bhagwan Sri Ram. What is the answer here? Bhagwan Ram is not the answer because he was there in something known as the Dwapar Yug, a Yug lot older than my and your age. What is the answer here? Sir, the answer here is V min is equal to, sir, root over 5 GL. Nothing else. Root over 5 GL, the answer still remains same. But here G gets replaced. G gets replaced by what? Bhagwan Ram? No. Not Bhagwan Ram. Then whom? His sons, Love and Kush. Or Ravana. With that 10 heads and a stupid looking beard which just came in this movie. And now they are removing the entire movie with the VFX. Because that does not look like a Ravana. Yes. What is the change here? Its answer is still 5.
QE by M.
Yeah, beta?
QE by M.
So G should be replaced by QE by M. That is what you are telling me?
Yes, sir.
No, that is not correct. Here the mass and gravity is also there, beta. This
sir.
motion is taking place on Earth. It is not taking place in space. This motion is taking place on Earth. So G is also there. G is always there. So remember this concept, and probably you are doing simple harmonic motion. So there you will come across cases where this G is replaced by G effective. This G will be replaced by G effective. And in this case, what is the value of G effective? To find out the value of effective G. G is already downwards. There is something also which has come downwards. What is that? Huh? Definitely not Bhagwan Ram. Or Love and Kush.
Yes, sir.
G effective will be G plus QE by M. Do we understand this?
Yes, sir.
So please note it down. G effective, G plus QE by M. Now remember, just don't remember this, understand the logic behind it. Why it is replaced by plus QE by M? Because the mass is, because the charge is experiencing force in the downward direction. If instead of this charge as positive charge plus Q, if this charge was negative minus Q, then what would be the answer?
Minus QE by M.
Because then that charge will experience force in the upward direction. So you have to write, instead of plus QE by M, you have to write minus QE by M. Do we understand this, or this is gone above and saying bye bye? Don't worry about me, I'm gone.
Understanding, sir.
Okay, so this is what you should have remembered. Remember root 5 GL. So whenever such question comes, just have to replace, or the question that we had done, you replace G by QE by M and the answers remain same. Having said that, let us move on to the next part of this electrostatic field. What we were doing, theoretically, it is known as motion of a charged particle in a electrostatic field. So if you want to write the heading, that was the heading of what questions we were doing. The name of the heading was motion of the charged particle inside electric field. We understand this? Let us move ahead with other type of questions. And what are the other type of questions? Now, let us start with this simple thing. Do you know what is the electric field due to a point charge? Tell me, what is the electric field due to a point charge? You must be knowing this, right?
KQ by R square, sir.
KQ by R square. Chalo, I will just write. The answer is KQ by R square. What is the direction of this field? So it does not have any direction. Does it have any direction, bacha? Or no? Does it have any direction?
Towards test charge, sir.
Towards test charge. Towards test charge is not a good way of saying this. If I have the charge, let us say plus Q here, and the point P here, can you now tell me what is the direction of this electric field created by this positive charge plus Q?
Q to P, sir.
From Q to P. If this was a negative charge, then if the charge was negative, then same direction or different?
Opposite, sir.
Opposite, sir, means from
Towards Q, sir.
okay. Okay, this is the electric field due to positive charge. But if you have different type of charge distribution, do you remember their electric fields due to different types of charge distribution? Yes or no? You will have to remember it, because I am not going to get into the derivations of those things, because it is just waste of time. We'll have to look at the different types of charge configuration and then find out the electric field. Okay, but before going into that, let me give you this question, because this question concerns your electric field due to a point charge. So let me give you this question. Okay, now remember, these are the type of question which I think, from my knowledge and understanding and experience, that can come in the examination hall, whether it is JEE Main or whether it is JEE Advanced. Calculate the electric field at origin due to an infinite number of charges as shown in the figure. Figure A shows 2. Figure A shows plus Q plus Q plus Q till infinity. Figure B shows plus Q, then minus Q, then plus Q, then minus Q till infinity. Simple question. Questions are always simple. You just have to get the right approach to solve them. Once you get that right approach, well, nothing in this universe is going to stop you from getting where you should be. So tell me the answer first so that I can move fast. And remember, whatever questions we have done previously of electrostatic force, the same question can be done for electric field. I told you that, yes or no? Huh? I told you that, yes or no?
Yes, sir.
ठीक है. Yes, बच्चा. Remember, this is a question of maths, not a question of physics. This is a question of maths, not a question of physics. Anyone? You just need to have the right approach and nothing else. Nothing else you need. Anyone with any answer? No one with no answer. No answer is no good.
3kq by 4.
3kq by 4 in which case, beta?
First case.
Plus k. Let me check the answer. Where is the answer? Huh. 3kq by? No, it is in first case the answer is 4kq by 3. And in the second case the answer is 4kq by 5. Do we have this? No one has this. Chalo. Shall I solve it?
Yes, sir.
So, what is the electric field in the first case? In the first case, the electric field E in the first case will be electric field due to charge 1 at 1 plus electric field due to charge 2 plus electric field due to infinite charge. All of the electric fields will be in the same direction. Yes or no?
Yes, sir.
They will get added up. Yes or no?
Yes, sir.
Now, if I find the electric field due to the first charge, it will be bacha kq by 1 square. Plus, if I find the electric field due to the second charge, it will be kq by 2 square. 1, 2. So it is getting doubled. Plus the second field will be kq by 4 square. Yes or no? And so on. Yes or no, bacha?
Yes, sir.
Yes, sir.
It's an infinite series. Kq comes out 1 by 1 plus 1 by 4 plus 1 by 16 and so on. I told you this is a question of maths, not a question of physics. Infinite series. Common ratio less than 1. A upon 1 minus R. Do we remember? Huh?
Yes,
Yes,
sir.
That is the answer. So what is the answer?
4/3 kq, sir.
Well done. Remember these, the same question you might find in the examination hall. That is E1. Now, can you quickly tell me the answer for E2? Fatafat.
Four by 5 kq, sir.
Yes, beta?
4/5 kq.
4 by 5 kq. Should I tell you how to do this? Here, the common ratio in the first case was 1 by 4. Now the common ratio is minus 1 by 4. So it is A upon 1 minus of minus 1 by 4. So it will become 1 plus 1 by 4. So 1 plus 4 by 5. 5 will come on the top. 1 plus 1 by 4. So 5 will remain in the denominator and 4 will come on the top. Do we understand this? Remember
Yes,
this
sir.
question, you may just find this question in your examination hall. Then please be strong enough and good enough to solve this question. And I saw one. Okay, where was this? Where was this? Is what's here probably. Okay, shall we move ahead? Now, I'm going to show you some graphs, and remember these graphs because I've seen question of this nature come in your JEE. So remember these graphs, keep them in your head. If you want to draw, you can draw them. These have been taken from your previous years. This is the electric field due to two charges, two positive charges placed here. The electric field will vary like this. They've asked many questions on this pattern. That is why I'm telling you. Two positive charges, electric field varies like this. You want, you can draw this. Two negative charges, the electric field goes the other way around. Electric field goes the other way around. Remember, the charges are same in magnitude, opposite in sign. Therefore, you have electric field becoming zero exactly at the center. Do we understand this, bacha?
Yes, sir.
So this is the point from where you can understand which graph is which one. If one is positive and the other one is negative, then the electric field zero will not become zero in between. Do we understand this?
Yes, sir.
And that is the example that I'm going to show you next. So with these four examples, I think you should be able to do any question of this class, this category, if it comes in your examination paper, because this actually covers everything, every type of question that I have seen up till now coming. So this is the third one where you have one positive charge, larger magnitude, and one negative charge of smaller magnitude. Now remember, where is the electric field becoming zero? It's always on the smaller charge side. Do we see this?
Yes, sir.
This is the point that you need to see, because in the examination hall, when they give this graph, they will give both the graphs. They will give zero on one side, they will also give zero on the other side. So remember these points. Simple things. But in the examination hall, you must be careful that you don't make the mistake of pointing noting the wrong option. This is the brother of this one, positive on this side and negative on the other side. You can see the entire thing has been reversed, and we have the charge like this. Everyone understands this, yes or no?
Yes, sir.
Note this down. Let me know once you are done. I'm looking for a pic.
Done, sir.
Have you done, sir? Okay. Good. Now, what we are going to do is we are going to note down electric fields due to some type of charge distribution. So we will note down the electric fields. We'll have to make a similar table when we come into the chapter of electric potentials, and we will write the electric potential of some common configurations that we see. So This is the first heading that you will write. Electric field due to what? Different types of charge distribution. So that is the heading you will write. We will not be able to complete it in this class, so we will continue with this thing in the next class. Electric field due to charge distributions. We are not going to get into the derivations because derivation is a waste of time. You just have to understand how they have come and remember those results, and that is the result that is going to come. The first one, we already know the electric field due to a point charge. Yes or no?
Yes, sir.
Now the next one that comes is a line charge. Line charge. Now how do you find the electric field due to a line charge? A line charge consists of basically a one-dimensional charge distribution. You break this line charge into small segments, dx, dx, dx. They become point charge, and then you add up because all the fields are going in the same direction. You add up and you get the electric field due to a line charge. Now this is electric field due to a line charge at any point on the axis. At any point on the axis, the distance of this point from the line charge is given as A, mere bacha, and the length of this line charge is given as L. Do you know? Do you remember the electric field due to this? Have you seen this electric field before?
Yes, sir.
What is the answer for this electric field? Tell me. Okay, I don't have time for your thing. 1 by 4 pi epsilon naught 1 by A minus 1 by L minus A. What is this lambda?
Linear charge distribution.
Yes,
Density.
this lambda is Q by L. So sometimes I might write it as Q by L. Sometimes I might simply write it as lambda, my dear friends. So this is the first what? First formula that you must remember. You know this, yes or no?
Sir.
Then comes the second one, my dear friends. Oops, why this has come here? Should come here. The second one is still a line charge, but this is a point perpendicular to it. Sometimes this point is on the perpendicular bisector, but here it is a general point. So we call this electric field at the general point. If you remember this field, you can find out electric field at all the points. So the length of this line charge, as you can see, is L. The distance of the point is R, and a very peculiar two angles are given. Remember this angle theta 1 and theta 2, because these two angles theta 1 and theta 2 are going to come till the last topic that we do in this chapter, electromagnetism. It will come in magnetic field also. So remember this. Do you know the formula for this one? Now, since it is not on the perpendicular bisector beta, if it was in the perpendicular bisector, then your x component will get cancelled. Yes or no? Yes or no?
Yes, sir.
But it is not on the perpendicular bisector, so it will have both the x component as well as the y component. The x component of electric field, please note it down, is given by this formula. Anyone know this formula? The x component of the field.
Lambda by 4 pi epsilon naught cos theta minus cos theta.
Cos theta
Cos theta, theta 2 minus T1, theta 1.
Okay, so you can write it like this: lambda by 4 pi epsilon naught. That is what you are saying. Lambda by 4 pi epsilon naught r cos of theta. Which theta? Smaller theta. Theta 2 minus cos of theta 1. This will be your x component. What about your y component?
lambda by 4 pi epsilon naught r into sin theta plus sin theta 2.
It is not less, it is added up. Both the components add up, they do not get subtracted. So remember that. They get added up, they don't get subtracted. Okay? We get this?
Yes.
Now, since you get this, remember every question that we do, we must follow it up with some sort of what? Of something that we understand. So this is your question, and that will end this class. And how do you solve this question is written right in front of your eyes. Question number 1, find the electric field at the center of the square. Remember this this is made up of 4 rods. Do you understand this? 4 rods. Find the electric field at the center. On the left hand side we have minus lambda, on the right hand side we have 2 lambda, top side we have minus 3 lambda, and bottom side we have 4 lambda. What is the electric field at the center? Now remember they are on the perpendicular bisector, so their x or whatever x or y coordinates will cancel out. Yes. Yes, bacha. Shall I help you?
7 lambda by 4 pi epsilon naught L.
Root 2 is not coming anywhere. Root 2, this, that. Okay, so what we'll do, we will try and solve this question in the next class. Remember, whenever you encounter such a question, you will have to compare it with the formula that you had made. The question should look the same as the formula. Otherwise, you cannot apply the formula. Do we understand this, bacha? Why I'm insisting so much on this question? Because the same question, if I just replace this line charge by current, this is a question of electric current and this is a question of magnetic field. And we'll have to do it again. So if we can build this habit that whenever you have a formula, now the formula is for the diagram which is shown here. So your question should look like this. Then only you can apply the formula. If your question does not look like this, you cannot apply the formula. Do we understand this? So we will see how I can make this question look like the previous one. We'll do it in the next class. Probably we'll be able to finish electric field in the next class. See, I am in no hurry. Whatever time it takes, it will take. And unless and until I am satisfied that you are done with electric field, you are not done with electric field. We have time that I can cover up the curriculum. I have found out the time, so don't worry about this. There is no point for me rushing on anything, and there is nothing that I will skip. So don't worry, we'll cover the entire course. I've sent you the sheet. Did you get the sheet? Yes or no for electrostatics?
Yes, sir.
You just concentrate on those sheets and the question that I am doing in the class. Apart from this, you should not do even a single question extra. Don't have to do it, because most of the question I will be covering in the class, and the rest of the question will be coming in your test. So don't worry. Everything is covered. Take care. I'll see you tomorrow. God bless you all. Bye bye.